Hello everyone, my name is Steve Samuel from Design Visionaries, and today I want to make sure that you can do lots of threads. I call this video Screw It Up, because we're going to do screws here. There's lots of helical forms that are necessary in product design, and NX has some tools that I think you should know about. They're really fantastic, and so I'm going to show you them one by one. So the very first thing I want to show you is the fact that you can do a thread on a cylinder. So if I create a cylinder, let's say I create a cylinder with 47 millimeter diameter and a height of 100, and I just put it there. I can then go to the feature more, the base more, and I can go to the thread function, thread, and I can make sure that the thread is set to detail. Here we go, detail. And I can select the cylindrical face, and I can give it a length here. And now, this is interesting. It says thread size. I'm going to do a 42 by 45. It says the shaft diameter should be 41.437. But if I go up to let's see. All right. So I say it's listing me that the M42 by 45 is a 41.435. So what I'm going to do is go back, and I'm going to double click on this cylinder, and I'm going to give it that suggested diameter, 41.35. And now I'm going to go back to the thread, slap it on there. Make sure it says 42, there's 41.435, and then I can just give it a length, the number of threads, if you will. So let's make this 50, there we go, or 60, what have you. Say okay. So it's important that you match up the diameter of the cylinder with the thread, because it's basically going to cut into whatever cylindrical surface that you give it. So that is one way to do threads very quickly. Very nice. Of course, lots of times when you're doing threads on something, it is best to give it symbolic thread if you can, if that's okay for the application that you have. So if I do another cylinder, let's call that, what was it, 41.35. And I'm just going to pop one right here, blink, like that. And then I'm going to go back to the thread function. Here it is, thread. And I'm going to do the detailed thread instead. And select this, the cylindrical face. And this one wants to be a 42.45, which I start with a cylinder of 41.437. I think I had said 41.435 before, but that's okay. And say okay, and oops. I wanted to go symbolic on this one. There we go, 42.45. And of course, what it makes is a thread callout, which is represented by these dashed blue lines. And these are important because when you do drafting, you can select upon them and you can get the actual thread callout. Great, so that is one way of creating screw threads. And very powerful, but you don't really have control over the thread profile or most anything. So in many cases, that is not really acceptable, or you just can't do it. You can't really use that. Okay. Next up is when you create the threads yourself. And so I'm just going to move these out of the way with a Control T. I'm going to make sure it says don't move the parents, do it associatively. And I'm just going to push them down here like this. There you go. And we're going to start with yet another cylindrical body. I'll just do a cylinder. This time I'm just going to do it random. Not random, but the size of my choosing. So this is going to be a cylinder of diameter of 50, height 100, and it's going to start right there on the origin. Say okay. Beautiful. So what I'm going to do next is I'm going to create a helical curve that goes up the side of this, and so I'm going to go to the curve function in helix. I'm going to select along vector. I'm going to grab this vector. I'm going to say that the diameter will be 50. Here's 50. The number of turns, just arbitrarily for this exercise, will be, let's call it 19. There we go. Say OK. So there's my helical geometry, the curve that's on the cylindrical surface. And then I'm going to go to the sketch, and I'm going to set the sketch on path. And I'm going to select this little path right here. I'm going to make sure the percent arc length is 0, so it brings that that plane to the end of the helix that I've created, and it's also normal to it. And I'll say OK. It'll throw me into a plan view of that sketch where I can sketch the profile that I want, the tooth profile, if you will. So I'll just do this real quickly. If this were a production job, I'd have some definite dimensions for this. I might give this a midpoint constraint where I can select the start point of the helix and the lines that make up the tooth profile. So now it's all centered and it's nice. I could put in a dimension if I want. So like so. So that's the height of the tooth. I'll make that 4. I could put a tooth width there, or the very end of this tooth can be, let's call it 2. And then I'm going to do something interesting. I'm going to put in a line segment that looks like this. And that's going to be a reference line. And I'm going to make sure that that reference line is mid-pointed. It's also going to be collinear with that axis there. And I'm going to say point on curve. So that point's going to go there. And then I can control the dimension, the base dimension of that tooth with that line. And you may be thinking, why don't I just take this line and put it up here? The answer to that question is when I sweep this tooth profile along the helix, I'm going to want to have some overlap with the with the form that I'm creating, or overlap this helical form with the cylindrical shape. Okay, so now I've got everything under control. I've got 4, 4, and 2. You can select the numbers that make the most sense for what you're doing. And now I've got to sweep this. So if I go into, if I try to use sweep along a guide, sweep along a guide is really nice. You select a section, you select the guide string, and as you can see, you don't really have control over what happens with the section as it goes along the helix. So that's why that's not usable. And so you have to be more sophisticated and use the swept command. So the swept command allows you to select a section like this, and you select the guide curve like this, and you also have to select an orientation method. And in this case, I'm going to use forced vector, and I'm going to select the vector that goes straight up. And now that controls the rotation of the section as it goes along the helix, as it's swept along the helix. You'll also need this little switch, the preserve shape, because without preserve shape, what happens is NX tries to make a single surface out of the whole profile. Watch this. When I take that off, what you can see is now there's not really sharp corners there. There's a seam, if you will, and then everything else is really trying to be smooth, and that will be bad because then I can't like put blends on here. It won't be separate surfaces. So as soon as I put preserve shape on, here we go, you can see that there's an actual surface segment. And one of the great things about NX is it's discoverable, meaning when you're doing these sweeps and you're using these different functions, when you're manipulating the different choices in these menus, you can automatically see, or I should say, you can immediately see what's happening because of the preview. So it's there discoverable. You can discover what it does before you say OK. So fantastic. So now that I've said okay, I can go into the Home tab and I can unite these two. Unite that together with that. Say okay. Maybe I don't like the way this surface is coming down. So I can then give it a trim, perhaps. I can say trim body. I'll select the body. I'll say give me a new plane that's on the bottom. And I'm going to just trim that off like that. And so then it's nice and threaded. Beautiful. Now let's get a little bit more sophisticated. And in order to do that, I'm going to start off with a sketch. I love sketches. And I'm going to sketch on a flat plane. There you go. And I'm going to make a helical function that looks like this on a donut. A helix on a donut. Okay. So look, I'm going to make this little guide curve, and it's going to be really important for me to put a dimension on the guide curve that looks like that. And it's important for me to record what parameter number this is. As a matter of fact, I'm going to give this a name like DD, okay? And I'm going to set it at, let's say, 120. Okay, so DD equals 120. That is the diameter of this form. DD 120. Great. Next, I'm going to put a tube on there. So I'm going to do surface more tube. And let's say I'm going to put an outer diameter of 10 millimeters on that tube, inner diameter of 0, or on that, that's a little too thin. Let's do 20. There we go. So an outer diameter of 20 on a tube that goes around this circle whose diameter is DD. Okay, now this is why this is important, because the next thing I need to do is put a helix on that tube, and it's got to go all the way around and rotate as it goes. And so I'm going to just hide this for a moment, and I'm going to go to curve helix. The helix command accommodates a long spine, and so we're going to use this curve as the spine. I'm just going to select upon it, and as you can see, it's trying to put a helix on that circular sketch. So good. So I'm going to make a diameter of 20. It's a good start. And I'm going to have a pitch of 5. So there's going to be 5 millimeters in between each turn. Then the number of turns is what? Well, we have DD is the diameter of that. We're going to multiply that by pi, so times pi left paren right paren. So that's the whole circumference. And then, of course, we're going to divide that by the pitch value. So I'm going to say divided by 5. And as you can see, now that goes all the way around, and it should start where it stops. But for some odd reason, there's a little thing missing. So I'm just going to say OK here. And let's see what we can do about that. So I'm going to put in, it looks like it's missing like 0.75 turns, number of turns. So I'm going to go to the formula editor, and I'm going to put some parentheses here. I love the fact that you can put these mathematical equations in X so easily. So I'm going to add 0.75 and see what happens. So for some odd reason, it looks like that blows it up. Let's see, that's a value, 0.75. Let's say okay. No, that's definitely not happy. So let's go back to the number of turns. Formula, what did I do? What did I do wrong? Let's do this, let's get rid of this. Let's enter that. 7.5. Okay, now this is a pitch we're talking about. Turns. Okay. Let's try that again. Okay, so I just undid it. And let's try going back to that helix command. The number of turns right now is 75. Okay, so if we go to the formula editor, 75. So right now that's 75. So if I put this whole thing in parentheses, I don't know what happened. Let's go all the way back here. There we go. And let's add plus 0.75. Okay, so now we've got 76.1 something or other, and that is definitely not happy. Not exactly sure why, but let's just reduce this a little bit. 0.1. Say okay. Nope, not happy. Oh, I know. Let's take that out. That's going to be happy, of course. And what we'll do is we'll go in with a studio spline and we'll select the end. We'll put a G1 continuity curvature. We'll go to this one right here and we'll do another G1. Then we will go to constraints. They need to be flipped around. So this one needs to go like that. And this one needs to go like that. And it's not pushing out as much as it needs to. So I'm going to go to G2 instead. Infer G2. Infer G2. Nope, that's not working. So there's one more trick that we have up our sleeve, and that is the bridge curve. So the bridge curve has a continuity G1 and G1. So we're going to select this one right here. Good. And then we're going to select this one there. Get that out of the way. There. Good. And now we're going to adjust the tangent magnitude until this comes to the right spot. And the tangent magnitude will be A equals 1.1. This has to be an equal sign. A equals 1.1. What's going on here? Like that. Good. And then this one equals A. Getting all kinds of troubles here. Okay. And now say okay. All right, so we made a variable called A that we can now go to user expressions and try different values for A until we get what we want. So there's A 1.2, 1.3. Okay, let's say 1.3. All right, so it's a little bit of a compromise. I'm sure mathematically we can make it perfect if we wanted to keep messing around with it. Okay, here's what's next. We've got a sketch that we need to place on the curve that goes on the surface. And what we're going to do now is we're going to say sketch on path. Sketch on path. I'm going to select the path. Here we go. We're going to make sure it says 0, so it goes to the beginning of the path. And we're going to make another tooth profile. This time I'm not going to constrain it and everything. I'm just going to put it in because we've already seen that. I'm going to hold my finger on the Control key so it doesn't try to, the Alt key, so it doesn't try to make a constraint with other entities. Do that. Let's do this. There we go. Good. And now another sweep. This time we're not going to use the forced direction. We're going to use the surface command. This bridge curve is not working out, so I'm going to delete it. Yep, delete. And now I'm going to, that's interesting. So the helix went a little too far and didn't go down far enough. Okay, think about that later. So now I'm going to do the sweep. So there's a surface, there's a more, there's the sweep, there's the swept surface. I'm going to select the section. I'm going to select the guide curve. I'm going to use a orientation method of face normals and select this tube-like face. I'm going to make sure that preserve shape is on and say OK. And there you have it. So there's a helical form bent around a donut. Okay, and sooner or later I've got to solve this problem. I'm not exactly sure why that's happening. I am going to try to go to that helix command and see what happens if I start with an angle of 0 and say OK. Now it's going to recalculate the whole thing. I've got my fingers crossed, and nope, angle of 0 should be very similar or perfectly the same as an angle of 360. Let's try 90. That was a nice shift. Interestingly enough, it still didn't do what we want it to. So we're going to have to do a little bit more thinking about that. Anyway, as you can see, it does make a helix that basically wraps around in a very nice way. Some little wild thing going on with this, but I think I'll probably just do some thinking about that. Okay, the very next thing is a helix on a conical shape. There are threads that are on certain conical shapes. If you're in the oil well industry, you know that the different tubes that come together when you're digging a well, the end of those tubes have a helical thread, and that way when they thread them together, they don't have to turn them as much, because you go down, you engage those threads on this cone, and then you only have to turn it like 1 turn instead of the maybe 10 turns that you would have to if it were a straight thread. So it's pretty cool to have a helical thread. And the way to do that is to create a profile. I'm going to just do it on this plane here. Okay, so I'm going to create a profile that looks like this, like that. Okay, again, I'm going to give this a dimension that I want to keep track of. And so I'm going to put a variable name of HH in here. And I'm going to go, let's say 120 high. So HH equals 120. There we have it. Okay. The next thing I'm going to do is I'm going to make a helix that is going to follow that curve. And as a matter of fact, I think I'm going to make it just a little bit more exotic by putting a spline on here. Okay, so we're gonna do something even more difficult. So let's do that. Okay. So there we go. So I want to make a shape that's going to be the revolve of this spline about that axis, but I want to put a helix on there and then put a thread on it, subsequent thread. So here we go. What I'm going to do next is go to the curve, go to the helix, and I'm going to say helix along spine. So I'm going to grab this as the spine. I'm going to have a pitch of 5. My number of turns will be HH, that's the overall height, divided by 5. There we go. So that gives me a helix that's perfectly the right height. But now I've got to control the radius. And so NX is pretty awesome, because you can go to the radius function and you can say, I want to control my radius by law curve. And what I'm going to do is I'm going to select the that spline right here as the law curve. I'm going to select a baseline of the curve that goes up the middle, And as you can see, the helix is now constrained to the contour of that curve. Awesome. So what I'll do next is go to the revolve function, revolve, and I'll select just that crazy spline, and I'll revolve it about the center line like so. So, okay, and as you can see, the helical form is distributed on the surface, on the revolved surface. And I will finish off with a sketch on a path. I'll grab that path. I'll call it 0, where it's starting. I'll say OK. And then I will create yet another tooth profile. I think this one will be a little bit more interesting. I'm going to start with an arc that looks like that. I'm going to put a little line segment that emanates from that little center line there. I'm going to go to the mirror command, where I will mirror that arc around that little doodad right there. I'm going to then just close it off with some lines. There's one there. There's one there. And there is my tooth profile. Beautimus. To finish off, I will go back to the swept function. My section is already selected. I'm going to go to the guide string of the helix. I'm going to select the face, so the helix will be driven along face normals. Oh, wait a second. I don't think I want face normals, because the face normals go in and out. I think I would rather have these teeth to be all horizontally oriented, and so I'm going to go to orientation method along a forced direction, and the forced direction will be straight up. And so now if you look at the profiles, they're all horizontal the way I wanted them. Say okay. Terrific. I want to unite these together, and I will, when I do the, if I want a shape that is if this is the screw, then to make the nut, I want that to be fitting these screw threads. So what I might do is go to assemblies, and then interface, and then select one of these as an interface, bring that into the nut profile and do a subtract, and then I have an exact subtract, and then I'd probably offset it a little bit to make a little bit of clearance. Anyway, that is a lot about helical forms and screws and this kind of thing. As you can see, NX has a number of really powerful techniques that are so easy to use, and I hope you've enjoyed this video. Please like and subscribe, and I will see you online. Thanks again.